Hello, it's me again, and this is to do with the limiting factors bit, which is at the end of the photosynthesis chapter. I think Maisie asked for some help here, and I'm sure this would help us all. And an investigation was carried out to find the effect of increasing CO2 concentration on the rate of photosynthesis in a particular type of plant. The graph shows the results. So that's typical. You can see the axes, rate of photosynthesis being on the left. Now, remember, in A-level, AQA, there's only 3 limiting factors that can be at play. Here it's carbon dioxide concentration, another one might be temperature, and then another one might be light concentration or light intensity. Okay, now both graphs for varying carbon dioxide, like we have here, or light intensity, look like this, which simply means this: if you got no carbon dioxide at point A over there, then there'll be no photosynthesis. The rate of photosynthesis is 0. If you increase the carbon dioxide concentration bit by bit, what you'll get is more photosynthesis, but then a point is reached whereby increasing the carbon dioxide even more in concentration won't actually increase the rate at all. Now, there's various reasons for that, but all you've got to remember is this, that between A and B, if you change, especially if you start decreasing the carbon dioxide concentration, you'll start decreasing and therefore limiting the rate of photosynthesis. So between points A and B, we can say that carbon dioxide can be a limiting factor. All right. If you go from a concentration of B and increase it to a concentration of C, though, then increasing the concentration of carbon dioxide doesn't increase rate of photosynthesis, and so at these concentration, carbon dioxide concentration is not a limiting factor. Something else is. Now, you could increase the temperature surrounding the plant. If you did, then you'd end up having a graph that goes higher and more steeply. You could alternatively increase the light intensity, at which point, once again, you'll get a graph which is higher and steeper. Okay, so that's virtually all there is to it. You're not asked to actually explain why CO2 can be cease to be a limiting factor between B and C. Okay, but if you are asked why it's important, remember you have to refer to how carbon dioxide will be fixed by RUBP, or with RUBP. Now, the next aspect are the questions. So in the investigation, temperatures kept constant. Well, remember, in any kind of investigation, you have to be absolutely sure that you only change one factor at a time. So you don't want temperature to start affecting the results. Suggest suitable units for measuring concentration. Well, that will be either 1 divided by time, yeah, in which case it will be time in seconds. That can be expressed as S to the 1 to the minus 1, yeah, to the power of minus 1. Or else you could just be counting how many oxygen bubbles are formed per minute. That's a bit GCSE, so how about the volume of oxygen produced per minute? That would be a rate, as long as something divided by time. Look at the mark scheme for alternatives, it's there below. Give evidence for the graph that carbon dioxide is limiting the rate of photosynthesis between A and B. Well, I've explained that already, so look at the mark scheme. Explain the shape of the curve between B, so I've explained that as well. So hopefully the mark scheme will make sense.